All right, guys, so we've begun a new unit. Well, it's not so much a new unit as it is a continuation. I know you guys are seeing these absolute value equations. It's been a long time, but you know what? This is the last unit on absolute value equations. So I just want to give you guys a head start on what we're going to be doing next. So the goal is, how do we solve absolute value equations if the bars are not isolated? Well, step one is get the bars isolated, okay? You got to get the bars isolated before you do any math, okay? Step two, if once the bars are isolated, you look, do the bars equal a positive output? So if the bars equal a positive, then you split the equation into two equations, one to represent forwards and one to represent backwards. However, if the bars are equal to a negative output, then there is no solution. It's a waste of time. If the bars equal a negative output, that means I can go a negative distance. And there's no such thing as negative distance. There's no way to reverse the tread on your tires. There's no way to undo the damage to my knees because I'm an old man. No, I'm just kidding. But yeah, there's no such thing as negative distance. Once you've done distance, you've done distance. Distance is distance no matter what. So just to get an idea of what we're doing, let's do these four problems, and notice there's a minor difference between them. So let's take a look at problem number one. This is a problem that you know how to do already. So find the solution set. Once again, I'm not pointing fingers at anybody in particular, but on the past two tests, I've had to clarify, find the solution set. You must find all values of x that make this statement true. There's not one, but two solutions, okay? So let's take a look at this. Are the bars isolated? For problem number one, the absolute value of x minus 3 is equal to 10. Yes, the bars are isolated. So what do? I'm looking for how do I get a distance of 10 units. So I split it into two possible outcomes. So either x minus 3 is equal to 10, or x minus 3 is equal to negative 10. And now I just solve for x. X minus 3 is equal to 10. So I'm going to add 3 on both sides. And that gets me x is equal to 10 plus 3, which is 13. No, we are not done, because I got to solve x minus 3 is equal to negative 10. So I'm going to add 3 on both sides. And now I get x is equal to negative 10 plus 3, or negative 7. So if I plug it back into the original equation, let's go with the positive output. 13 minus 3 is 10, but the absolute value of 10 is 10, so that checks out. Now let's plug in x equals negative 7. Negative 7 minus 3 is negative 10, but the absolute value of negative 10 is also 10, so there are two ways to get that solution. Okay, well, this makes me nervous. Okay, well, not too bad, because it's just the absolute value of x. So what do you think I need to do for this particular problem? Step one, get the bars isolated. So the bars are right here. So pretend this is bars minus 3. How do I get bars isolated? Right, I'm going to add 3 to both sides. So I got to do algebra before I do algebra. Can you believe that? So I'm going to add 3 on both sides. And now I've got the absolute value of x is equal to 13. Now, are the bars isolated? Yes. So now I'm going to split this into two separate solutions. Either x equals positive 13, or x equals negative 13. I want both solutions because I'm looking for the solution set. So let's plug them back in. The absolute value of 13 is 13. 13 minus 3 is 10. and that's what I want. Let's plug this back in now. X equals negative 13. The absolute value of negative 13 is 13. 13 minus 3 is 10. That's exactly what I want. It's not that big a deal. Okay, so let's turn the other side. See if you can do these two problems independently. Okay, there's only one minor difference. Okay, so let's take a look at this one. Are the bars isolated for problem number 3? Yes. Does it equal a positive output or a negative output? Positive output. So what I need to do is take the inside equation and split it into two equations. Either x plus 14 is equal to 20, or x plus 14 is equal to negative 20. And now I'm going to solve for x. Let's start with the right side. How do I undo x plus 14 equals 20? I want to get that x isolated. So what I'm going to do is subtract 14 from both sides. And that gets me x equals 20 minus 14 is 6. Okay, am I done? Nope, I got to do the left side equation. So x plus 14 is equal to negative 20. And now I'm going to subtract 14 from both sides. And on the contrary, negative 20 minus 14 is negative 34. I'm going to plug those solutions back in. Let's start with x equals 6. 6 plus 14 is 20. The absolute value of 20 is 20. We win. I'm going to plug in x equals negative 34 now. Negative 34 plus 14, well, that's negative 20. But the absolute value of negative 20 is also 20. We win with both of these solutions in the solution set. Now, what's the minor difference here? The bars are not isolated. So what do you think I need to do? I got to do algebra before I do algebra. So I'm going to get the bars isolated by subtracting 14 from both sides. Now, I've got the absolute value of x is equal to 20 minus 14, which is 6. Is this problem solvable? Yes. So now I'm going to take the inside, I'm going to break it into two separate parts. Luckily, it's only one step, because either x equals positive 6 or x equals negative 6. Let me fix the focus really quick. There we go. So now I'm going to plug in these two solutions back into the original equation. So let's plug in 6. The absolute value of 6 is 6. 6 plus 14 is 20. We win. Let's plug in negative 6 in for x. What's the absolute value of negative 6? 6. So 6 plus 14 is 20. We win yet again with x equals negative 6. So with that being said, now we're going to do these 4 problems and we'll call it a day. Find the solution set. Okay, pause if you want to do this independently. Okay, so now we're in business. Are the bars isolated? No, I got to do a little bit of algebra before I do my algebra. Let me get a pencil. Okay, here we go. So I want to get these bars isolated. So I've got the absolute value of x plus 4 minus 7 is equal to 13. So I want to get rid of that minus 7, because think about it. If I just put my finger right there, I've got bars minus 7. So I got to do the first part. I got to get bars isolated. How do I get bars isolated if it's bars minus 7? I'm going to plus 7 on both sides. So if I add 7 to both sides, I'm left with the absolute value of x plus 4 is equal to 13 plus 7 is 20. Is this problem solvable? Yeah, because I've got a positive output, so now I'm going to take the inside and make two separate equations out of it. Either x plus 4 is equal to 20, or x plus 4 is equal to negative 20, and now we're in business. So let's solve for x now. We've got x plus 4 is equal to 20. So I'm going to subtract, I got a little ahead of myself. I'm going to subtract 4 from both sides. And now x is equal to positive 16. I like. But I'm not done because I got to solve for the other equation. X plus 4, sorry about that, is equal to negative 20. So I'm going to subtract 4 from both sides. And now x is equal to negative 20 minus 4 is negative 24. So let's see if we got the same solutions. Put the focus back on. So if I plug in 16 plus 4 is 20. The absolute value of 20 is 20. And 20 minus 7 is in fact 13. We win. Let's plug in x equals negative 24. Negative 24 plus 4 is negative 20. The absolute value of negative 20 is 20. 20 minus 7 is 13. We win again. All right, number 2. The absolute value of x minus 8 plus 3 is equal to 12. How do you think I undo the layers to get the bars isolated? That's right. I'm going to put a little bookmark right here and say bars plus 3 is equal to 12. I want to get bars isolated first before I do the algebra. The algebra before the algebra. So let's do that. We've got the absolute value of x minus 8 plus 3 is equal to 12. I want to get bars plus 3. I want the bars. I want the bars isolated. So I'm going to subtract 3 from both sides. So now I've got the absolute value of x minus 8. 12 minus 3 is 9. So now, is this problem solvable? Yeah, I'm going to split this up into two cases. Either x minus 8 is equal to 9, or x minus 8 is equal to negative 9. So I've got x minus 8 equals 9. And I'm going to undo the layers of x by adding 8 to both sides. So that means x is equal to positive 17. That's one of the solutions. Let's solve for the other. Now I've got x minus 8 is equal to negative 9. Oops, sorry about that. So I'm going to add 8 to both sides. Negative 9 plus 8 is negative 1. So in this absolute value equation, either x equals 17 or x equals negative 1. Let's plug it in and find out. So if x is 17, 17 minus 8 is positive 9. The absolute value of positive 9 is positive 9. 9 plus 3 is 12. So that works. let's plug in x equals -1. -1 minus 8 is -9. The absolute value of -9 is 9. 9 plus 3 is 12. Okay, 2 more problems, then we'll call it a day. The absolute value of x minus 7 minus 10 is equal to 16. Let's solve for the absolute value solution set. Well, are the bars isolated? No. So I'm going to put my finger on this. I'm going to put bars minus 10 is equal to 16. Bars minus 10 is equal to 16. So I'm going to undo minus 10 by adding 10 on both sides. I want to do the algebra before the algebra. So let's add 10 to both sides and get the bars isolated. So I've got the absolute value of x minus 7 is equal to 26. Now, is this problem solvable? Yes. The absolute value is equal to a positive output, so I can split this into 2 equations. Either x minus 7 is equal to 26, or x minus 7 is equal to negative 26. Now, let's solve for x. So now x minus 7 is 26. I'm going to add 7 to both sides to undo the layers of x. Leaves me with 26 plus 7. Well, 6 plus 7 is 13. Carry the 1. You get x equals positive 33. Now, let's do the other part where x minus 7 equals negative 26. And if I add 7 on both sides, I get x is equal to negative 26 plus 7, or 7 minus 26. That would be negative 19. So let's plug it back into the original equation. Let's plug in x equals 33. 33 minus 7 is 26. The absolute value of 26 is 26. And 26 minus 10 is in fact 16. Let's plug in the other one. X equals negative 19. Well, I'm going to plug in negative 19 in for x. Negative 19 minus 7 is negative 26. But the absolute value of negative 26 is in fact 26. 26 minus 10 is 16. 2 ways of getting the exact same solution set. Last problem, and we'll call it a day. The absolute value of x plus 5 plus 14 is equal to 54. Are the bars isolated? No. I got to do algebra before I do my algebra. So I've got bars plus 14. How do you think I'm going to undo bars plus 14 to get bars isolated? Right, I'm going to subtract 14 from both sides. So the absolute value of x plus 5 is equal to 54 minus 14, or 4 minus 4 is 0. We get 40. Is this problem solvable? Yes, so I'm going to split this into 2 separate equations. Either x plus 5 equals 40, or x plus 5 is equal to negative 40. So I've got 2 equations. Let's start with the right side. So I want to undo the layers by subtracting 5 from both sides. That cancels out the plus 5 and the minus 5, leaving me with 40 minus 5 is 35. And now, x plus 5 is equal to negative 40, I'm going to do the same thing by subtracting 5 from both sides. And now, negative 40 minus 5 is negative 45. Okay? So let's plug it back in and see if we got the same solutions. So let's plug in 35. X equals 35 means 35 plus 5 is 40. The absolute value of 40 plus 14, the absolute value of 40 is 40. 40 plus 14 is 54. Let's plug in negative 45 in for x. Negative 45 plus 5 is negative 40. But the absolute value of negative 40 is 40. 40 plus 14 is 54. Two ways of getting the exact same output. Have a great day.